Welcome to the Chapter 27 slides, Basic Tools of Finance. These are really just the absolute rudiments of something that is a very complex topic, but what we're going to need for the rest of this book. So we'll learn a lot of definitions that I would recommend memorizing. Flashcards would be a good thing. And our first slide. Here are some things we're going to be learning. Terms like present value, which are very important, risk aversion, and what that means. And towards the end, we're going to be talking about the efficient market hypothesis. Very famous hypothesis, a great one to talk about during Christmas time to impress your uncles and aunts is correctly drop the use of the phrase efficient markets hypothesis and see it how much you respect it. Now this guy looks very mean, and I'm not sure who he is, but if you work in finance, you have to have a face that looks like this guy. Okay, you've got no smile. Okay, glasses slightly down the bridge of the nose. Okay, very important stuff. Okay, but in all seriousness, the financial system, it coordinates all savings, okay, all investment, so very big job. And they look at the allocation, how to save the scarce resources they have, okay, and figuring out where to best use the money to achieve their goals. Not necessarily to make the most money, because we're going to look at risk, but how to allocate it most effectively. And okay, you need to learn these two definitions. Present value is what is the present value of a future sum of money. A future value is the current value of a sum of money in the future. Okay, and all of those you need to know what the prevailing interest rate is. Okay, so this shows the effect of future value. Okay, what $100 worth today is at 5% interest 1 year from now, 2 years from now, and 3 years from now. Notice that this has what's called compounding interest. In the first year, everyone knows that at 5% interest, this investment is going to make $5. Okay, but that does not mean it's going to make $5 every year in perpetuity. Actually, the interest is going to go up and up and up. The reason that this is 110.25 and not just 25 is because they are the first $5, the jump from 105 to 110 is the interest on the original 100. This last little 25 cents is the interest on this $5 that they made in the first year of the investment. Okay, so this is a very simple formula. Okay, there's the future value formula. I would put that on a flashcard. Okay, so as you can see, you can derive the present value equation from the future value equation. So I'll just give you a couple moments to look at this slide, and this is how you determine present values. It's this equation right here. So here we are. I'll just clean this up and cross that out. So here is an example with General Motors. Okay, should they spend $100 million to build a factory that will yield $200 million in 10 years? One of the key variables they have to look at is what do they think the real interest rate is? Okay, and they say it's 6%. Okay, so it sounds like you're doubling your money in 10 years, which would generally be a good investment. However, the present value of $200 million 10 years from now is not $200 million. You plug it into the equation, and what you get is the present value is $110 million. Okay, so it's still a good deal. They're still, in theory, making $12 million. Okay, but it's not the $100 million it was cracked up to be. Okay, this was making it look like they're doubling their money. Okay, but they're not, because it's taking 10 years, and the present value of that $100 million gain is not $100 million. It's actually only $12 million. Okay. Now, just to show you how important the interest rate is if the interest rate is 9%, you'll see that if they spend $100 million today to have it become $200 million in 10 years, okay, that the present value of that $200 million is only $84 million. Okay, so they're actually losing money on this. Okay, according to this model, they would be better doing nothing with this money and putting it under their bed than to do this investment. And I want you, everybody, to take a minute before I go to the next slide to look at this box. Okay, next slide. So I'm going to pause it here, and I'll let you do this equation. And here are the answers. So at this interest rate, you should buy the lot, okay, because $78,350 is greater than $70,000. But at an interest rate of 10%, they should not buy the lot because this is worth less than that. Okay, so the present value of $100,000 in 5 years is worth less than $70,000. So that would be a bad investment. Okay, and if you think this doesn't happen, these type of things happen all the time. All the time. Over and over and over again. Okay, this equation happens all over the place. Okay, compounding interest. Compounding really shows you the value of what an investment can do if it's held for a long period of time. And what happens with the accumulation of the interest earned on top, earning the interest on your interest. And I think this is a great example. Okay, if you bought $1,000 worth of Microsoft stock and you held it for 30 years, okay, if the rate of return is 8%, okay, you're still making out very well. Okay, you're making in 30 years, you're making 1,000% increase. However, at just a few percentage points higher, you're doing almost twice as good. Okay, so it just shows you how a couple percentage points here and there can really shift a financial decision in a very significant way. Okay, the rule of 70 is a very popular rule, and you'll hear it talked about in politics sometimes, but all it is you take the equation of 70 over x, and x is the interest rate, and that gives you years to double. So here, at a 5% interest rate, 70 over 5 equals 14. So it will take 14 years to double. Okay. At a 7% interest rate, it will be 70 over 7, which will equal only 10 years. So you'll see how the interest rate on deposit makes a significant amount of money. Now, in this chapter, all they're talking about is interest rate. In the real world, there's no such thing as an interest rate that pays 5 or 7%. Okay, you're looking at an investment that's going to pay 5 or 7%. Okay, and with the higher return also comes higher risk, which is what we will get to further down the road. But know the rule of 70. You will be tested on it. It's a pretty simple equation, so just memorize it real quick. Okay, then the last slide we're going to do in this section is to talk a little bit about risk aversion. Okay, most people are risk averse. Okay, they're not huge risk takers. Not all of us wanted to get into that Red Bull balloon and get at the top of the atmosphere and jump out. Okay. In this example, should you take this gamble? No, you shouldn't, because it's a 50-50 gamble. Okay, yet every year, some people will gamble on the outcome of the coin flip at the Super Bowl. So that is what risk-averse people are. Okay, they don't like the uncertainty. They don't like the risk. Believe it or not, most people are risk-averse. Okay, so we'll get into some more definitions in a moment. I'm going to pause here, and we can begin in the next lecture.